All right, here's another example. And those that are counting eye rolls, you might want to get your counter ready. This has to do with the coin flipping analogy. And one way to think of a qubit is take a coin and flip it up in the air and have a strobe light. As the coin, let's say you start with a 1, and you just assign arbitrarily, say heads is a 1, tails is a 0. You flip it up in the air and you get a strobe light and you hit it. As it flips through the air, when the strobe goes off, you're liable to see the coin in various different positions. It might be vertical, it might be horizontal, might be an angle 45 degrees, somewhere in between. But what it's doing is it's rotating through all possible combinations of 1s and 0s as it's flying through the air. That's one characteristic of a qubit when it's in superposition. Another one that's totally alien to the conventional world is phase. Let's assume there's a date on the coin, and that date is facing the person when they are holding it. And then as they flip it and as it rotates through the air, it not only flips over and over, the coin actually rotates a little bit. And when it lands, let's say it lands heads, but the date is now rotated 90 degrees. That's the phase of it. And the reason that's important is there are programming gates and that you can use in a quantum that take it some advantage of that particular capability to try to reach the answer you're looking for. All right. And these are just as a summary. These are some of the qubit and superposition. These are just some of the things that they can do. And a quantum or a classical bit can only be a 1 or 0. If it's in between a 1 or 0, having designed many computers in my life, that's called an error, and it will shut down. Whereas a quantum computer lives its life during operation in between a 1 and a 0.